Welcome to my YouTube channel. Today is our lecture number 7. In the last lecture, we have seen that the matrix equation Ax equals b has the same solution set as the vector equation x1a1 plus x2a2 plus and so on plus xn equals b, which in turn has the same solution set as the system of linear equations with augmented matrix, this one. This is a very powerful tool for gaining an insight in linear algebra because a system of linear equations may now be viewed in 3 different but equivalent ways. For any real-life problem, one is free to choose whichever viewpoint is more natural. Similarly, one is free to move from one formulation to another when convenient. For example, in future topics, in linear transformations, we will be very much concerned with this matrix equation form. Now we discuss the linear independence and linear dependence of vectors. So, an indexed set of vectors v1 up to vp in Rn is said to be linearly independent if the vector equation x1 v1 plus x2 v2 plus xp vp equals 0. What do? That we form a linear combination of these vectors and we equate this to a null vector, and what do we expect? That if this system has the trivial solution only, then we say that these vectors are linearly independent, and if this system has trivial solutions also, then we say that these vectors are linearly dependent. And in this case, the relation 2, this relation is called the linear dependence relation among v1 up to vp. As an example, we consider 3 vectors in R3. So v1 is 1, 2, 3, v2 is 4, 5, 6, and v3 is 2, 1, 0. And we ask 2 questions that determine if the set of vectors v1, v2, v3 is linearly independent. And number 2, if possible, find a linear dependence relation among v1, v2 and v3. Now to determine the linear independence, as described previously, we check whether the system x1 v1 plus x2 v2 plus x3 v3 equals 0 has a trivial solution only. Now this system, as described previously, has the augmented matrix 1, 2, 3, 4, 5, 6, 2, 1, 0, and on the right hand side here we have zeros, which can be reduced to an echelon form matrix as this. Now in this case we see that this is a pivot position, this is a pivot position, and here in the third row there is no pivot entry, and hence x3 is a free variable. And since x3 is a free variable, hence the system has non-trivial solutions, and thus v1, v2 and v3 are linearly dependent by our previous definition. Now to find a linear dependence relation, we proceed as follows. We further reduce the augmented matrix to a reduced echelon form matrix. So the reduced echelon form matrix can be obtained as this one, and here now we see that x1 minus 2x3 is 0, providing x1 equals 2x3, and here we have x2 plus x3 equals 0, so x2 is minus x3. Now since x3 is free, so we can choose any value for x3. For example, in this case I picked the value 5, and this value of x3 produces x1 to be 10 and x2 to be minus 5. And if we substitute these values in this relation number 1, what do we have? We have 10v1 minus 5v2 plus 5v3 equals 0 is 1 out of infinitely many, because we know that the system has non-trivial solutions, so there are infinitely many solutions, and this is of course one of the possible linear dependence relation among v1, v2 and v3. And hence if a set of vectors is linearly dependent, then the linear dependence relation among the vectors of that set is, of course, there are infinitely many linear dependence relations. Now we discuss the linear independence of the columns of a matrix. So suppose we have a matrix A with columns A1, A2 and AN. Then the matrix equation Ax equal to 0 can equivalently be written as the vector equation x1 a1 plus x2 a2 and plus xn equals 0. Then each linear dependence relation among a1, a2 and an, the columns of A, corresponds to a non-trivial solutions of Ax equals 0. Hence, if we consider any linear dependence relation among a1, a2 up to an, it corresponds to a non-trivial solution of Ax equals 0. Thus, we conclude that the columns of a matrix A are linearly independent if and only if the equation Ax equals 0 has the trivial solution only. For example, if we consider this matrix and we want to determine that whether the columns of this matrix are linearly independent, so what do? We consider the matrix equation Ax equals 0, which has the augmented matrix as this. If we reduce this to an echelon form matrix, we have this one. Here, this is pivot, and this is a pivot entry. Hence, x1, x2 and x3 are basic variables, and hence the system has trivial solution only. And since this system has the trivial solution only, so by our definition, the columns of A are linearly independent. Thank you.